So here in this problem, we are provided with 2 points and both of the coordinate values are given. So point A has the coordinate value a comma b and B has the coordinate value c comma d. And then what we need to do here is we need to show that the line segment that connects these points is going to form an angle theta with the origin. And if we take the cosine of that angle theta, then this is given by the expression AC plus BD divided by square root of the product of a squared plus b squared and c squared plus d squared. Let's try to understand this problem graphically first. So for simplicity, we'll suppose that both the values a, that means the x coordinate of point A and y coordinate of point A and the x and y coordinate of point B all are positive. So that means they're going to lie in the first quadrant. Let us suppose that the point A with coordinate a comma b lies in the first quadrant. So similarly, B is also going to lie in the first quadrant. Now we're going to join the point A with the origin and we're going to join point B with the origin as well. And it's going to subtend an angle theta at the origin. So we have to show that cosine of this angle theta that's given by this particular expression. Okay, so what shall we do is we are going to join point A and point B. Fine. Let's specify the rule of cosine. Let's say we have a triangle ABC. Now the side opposite to angle A, so that's BC, we're going to represent it by the letter A in lowercase. Then we have angle B, the side opposite to angle B, which is AC, we're going to represent it by the letter B in lowercase. And the remaining side, which is AB, that's the side opposite to angle C, so we're going to represent it by the letter C in lowercase. Then the law of cosine states that, let's say we start with cosine of angle A. So cosine of angle A, that's going to given by, now we'll have to do is take the side adjacent to angle A, so that's either B or angle C. We'll take square of those sides, so we'll take B squared plus C squared, and from it we're going to subtract the side or square of the side opposite to it, so that's A squared, divided by 2 times the product of the side adjacent to angle A, that's BC. Similarly, if we let's say take angle B, then cosine of that angle B, so what we'll have to do is consider the sides that's adjacent to angle B, so that's going to be side C and side A. So we take this square and add them to each other, and from it subtract this square of the side which is opposite to angle B, so that's going to be B squared, so divided by 2CA. So that's how we can find out the cosine of any angle if the sides of the triangle are known. So this is known as the cosine formula. So what we'll do, we're going to apply this particular cosine formula to our triangle AOB. So let's do that. In triangle AOB, since we need cosine of angle theta, so cosine of angle theta will be given by, so what do we need? We need the side adjacent to angle theta, so that's OA and OB. So we take the square of the side OA, add it to square of side OB, and this will be from them, so we are going to subtract the side opposite to angle theta, which is AB. So that means we have AB squared, which will be divided by 2 times. We need now the side adjacent to angle angle theta, so that's OA and OB. So that means this will be product of OA and OB. So that means we need to find out the sides, the length of the sides of the triangle. So how do we determine the length of the sides of the triangle? For this, we'll have to use the distance formula. So let us specify the distance formula. So let us suppose that we have 2 points, point A and point B, and both of the coordinate values are given to us. If we join point A and point B with the help of a straight line, then the length of AB is given by the distance formula, which is simply take the square root. Underneath the square root, first we'll take the difference of the x coordinate and square this value, that's x2 minus x1 squared, and add it to the square of the difference of the y coordinate, meaning take y2 minus y1 and then square this value. So this is how we can find out the distance between any 2 points. So here we have to find out the length OA, AB and BO. So we'll use the distance formula. Let us begin. So we'll start with OA. To apply the distance formula, all we have to do is first consider the square root. Underneath the square root, what we have to do is take the difference of the x coordinate and then add it to the difference of the y coordinate. So let's start with the difference of the x coordinate. Here we'll do it carefully. Since we have OA, so we will start with the x coordinate of A first. The x coordinate of A, so that's going to be A, and from it we subtract the x coordinate of O. Now O being the origin, so its coordinate is going to be simply 0, 0. So that means the x coordinate of O is simply 0. Then moving on to the y coordinate part, so we'll start with the y coordinate of A first, so that's B, and from it subtract the y coordinate of the origin O, so that's also 0. Fine. So this is going to give us square root of a squared plus b squared. Fine. So we'll keep this aside. Then let's try to find out the value of OB. So OB is going to be equals to, we'll take the square root. Underneath the square root, what we need is the difference of the x coordinate. So since we have OB, we'll start with the x coordinate of b first. So that's c. So we have c. From it, we're going to subtract the x coordinate of the origin. So that's 0. So we have c minus 0 squared. And to it, we are going to add the difference of the y coordinate. So that's going to be d minus 0 squared. So we're going to get the value square root of c squared plus d squared. Now we will try to find out the value of the length AB. So AB is going to be, so we'll take the square root. So what we need here is B, since we're considering AB, so we need C minus A. C minus A whole squared. Added to it will be D minus B whole squared. So this is the length of AB. Now what we can do, we can substitute all this value back into this particular equation. So we have cosine of theta. So this will be equals to, so we need OA squared. We have OA, which is square root of A squared plus B squared. So if we square it, the square root sign goes away. So we have A squared plus B squared. This will be added to OB squared. So OB squared will be simply C squared plus D squared. From it, we have to subtract AB squared. So this is AB squared, which is simply C minus A whole squared plus D minus B whole squared. Fine. This will be divided by 2 times we have OA. So OA is simply square root of A squared plus B squared. Multiplied to it will be OB. So OB is simply square root of C squared plus D squared. Okay, fine. So let's now try to simplify the numerator portion. So we have A squared plus B squared plus C squared plus D squared. Minus, so C minus A whole squared, that's going to be C squared plus A squared minus 2 times CA. That will be added to D minus B whole squared. So that's D squared plus B squared minus 2 times DB whole divided by, so we have 2 times square root of A squared plus B squared. Multiplied to it will be square root of C squared plus D squared. So let's open up the parentheses in the numerator. We are now left with A plus B, A squared plus B squared plus C squared plus D squared. So we have negative C squared minus A squared. We have plus 2 times CA. Then we have negative D squared, negative B squared, and positive 2 times DB. Whole thing will be divided by, we have 2 times square root of A squared plus B squared. Multiplied to will be square root of C squared plus D squared. So here, A squared, negative A squared, B squared, negative B squared, C squared, negative C squared, D squared, and negative D squared all gets cancelled out. And in the numerator, we're left with 2 times AC plus BD whole divided by, we have 2 in the denominator, multiplied to it is A squared plus B squared times a square root of C squared plus D squared. So here we can factor out 2 from the numerator and the denominator, and we get the expression cosine of theta equals to AC plus BD whole divided by, so we have denominator A squared plus B squared. Multiplied to it will be square root of C squared plus D squared. So this is what we were asked to prove, hence proof. So also let's verify with the problem. We had cos theta equals to AC plus BD divided by square root of A squared plus B squared times C squared plus D squared, hence proved.